So today we're going to be looking at 17.1, Understanding Polynomial Expressions. The first thing that I want to point out to you guys is the essential question, which is what are polynomial expressions and how do you simplify them? So hold that in mind as we go throughout this lesson. That's something that I want you guys to be able to answer when we're finished. And so again, like I said, keep that in mind. But we're going to go ahead and start on page 805 and we're going to move to page 806. But a monomial is an expression consisting of a number, variable, or product of numbers and variables that have whole number exponents. Okay? Terms of an expression are parts of the expression separated by plus signs. So, something to remember is x minus y, can be written as x plus a negative y. It's the same thing, just written differently. So, a monomial cannot have more than one term, and it cannot have a variable in its denominator. And so we're going to look at this table. We're going to start here with the monomials. So 4, that's going to be one term, and so we know that it is a monomial. We have x, again, one term. It is a monomial. Negative 4xy, so it's a product of numbers and variables. Again, it's one term. 0.25x cubed, again, product of numbers and variables that have whole number exponents, so 3 is a whole number, so that qualifies as a monomial. And then xy over 4. So again, the variables are in the numerator here. They're not actually in the denominator, and so this is a monomial. Okay, so now we're going to use the following process to determine if 5ab squared is a monomial. Okay, and so we're going to just scroll down a little bit here, and we're going to start at A. And I want to point out that 5ab squared has blank term or terms, so it blank could be a monomial. Well, we're going to go ahead and fill that in. So it has one term, so it could be a monomial. Okay, so make sure that you guys are writing this down, taking these notes along with me. Does 5ab squared have a denominator? Well, no, it does not. Okay, if possible, split it into a product of number and variables. Well, that's something that I'll be able to do, and so I'm going to say 5 times a, and then I have b squared. Okay. So now we're going to list the numbers and variables in the product. And so the number that we have is 5. And the variables are going to be A and B. Okay. And so we're going to continue on. We're going to check the exponent of each variable. So we're going to complete the following table. And so we notice that the exponent on A is actually going to be 1. Right, because we only have one A, and then our exponent on B is going to be 2 because we see that it is squared here. Okay, so remember that B squared is really just B times B. Okay, so the exponents of the variables in 5ab squared are all what? Well, they're all whole numbers. Okay, therefore 5ab squared is a monomial. Okay, so let's go ahead and look at G. Is 5 over k squared a monomial? Well, if we go back up to our rules here, we know that a monomial can't have more than one term, and it cannot have a variable in its denominator. So if we go back down here and we look at 5 over k squared, we see that it cannot be a monomial because there cannot be variables in our denominator. So because a monomial cannot have a variable in the denominator. So we're going to continue on, and we're going to complete this table below. And so first I just want to make sure that we understand whether or not it is a monomial. And so if we're looking at a monomial, we're going to go ahead and use green. And so for every term that's a monomial, we're going to put yes. Okay, so 5ab squared, we determined that was a monomial. And we know that x squared is going to be a monomial because we have that whole number. So we're going to put yes here. We know that the square root of y cannot be because the whole number on the variable, there is no whole number on the variable, sorry. It actually is y to the 1/2, and that's a fraction. 2 squared is going to be a monomial. 5 over k squared, we already determined that it was not. 5x plus 7 is going to be no, because we see that there's our first term and our second term. Again, with x squared plus 4ab, we have a first term and a second term. And then we have k squared over 4, which, yes, that is going to be a monomial. So now we're going to go in and we're going to explain our reasoning. So for x squared, we know that it's a monomial because x squared is the product of the variable x 2 times. Okay, so make sure that you guys are writing this, filling this out. And so I kind of already went over why this is not one. We know that variables cannot, or sorry, let's rewrite that. Must have whole number exponents. One half is a fraction. Okay. 2 squared is just 2 times 2, which gives us 4. And so we would say something very similar as we said in the first one. Okay, so 2 squared is the product of 2 times. Okay, so 5 over k squared, we established that that is not a monomial because monomials cannot have variables in the denominator. Okay. And then 5x plus 7, we know that there's 2 terms. Okay. And a monomial cannot have more than 1 term. I went into this next box because both of these are actually going to be the same answer, right? Because we see that there's 2 terms in both of these. Okay, and then k squared over 4 is the monomial because k squared over 4 is the product of the variable k 2 times times 1 over 4. Okay, and so let's go ahead and move on. So if we're looking at the reflect, explain why 16 and 1/3 is a monomial, but x to the 1/3 is not a monomial. So the only reason that this is because it's a whole number, because it's a number, right? So a number can have an exponent of 1/3, but exponents on variables must be whole numbers. 1/3 is a fraction. So is x to the 0 a monomial? Justify your answer in 2 ways. And so I'm just going to say in one way. So think about it. X to the 0. I know that we've kind of gone over this. X to the 0 is going to be 1. So y to the 0 is going to be 1. Z to the 0 is going to be 1. 4 to the 0 is going to be 1. Anything to the 0 power is 1. So we know that if we have 1, we have one term, which means that it is monomial. So x to the 0 is equal to 1. And 1 is a number. Okay?